gentlemen, this is Intro to Atomic Theory and correlates to Chapter 5.1 in your textbook. Your key concepts for this video are, how did atomic theory develop, and what is the modern model of the atom? So atomic theory is continually being changed to this day. We're adding more and more to it as our understanding of atoms becomes better. But we're going to focus on the 5 main people that really brought it to where we kind of are now. But first, we've got to talk about how we even got the word atoms. So back in 430 BC, Democritus was a Greek philosopher and scientist. He came up with the name atoms. He decided that all matter was made of these tiny, indivisible pieces and called them atoms. Now he thought that they were made of the same material but had different shapes. So a water atom would be round and smooth because water flowed, whereas an iron atom would probably be bumpy because it was all rough and hard. He was wrong about the indivisible and the shapes, but we got a name from him, which is pretty good given that a lot of people didn't even think matter had atoms. So fast forward to 1803. John Dalton decided to expand on his idea of atoms and give us really a good framework for the beginning of atomic theory. John Dalton said that atoms can't be divided, so he agreed with that indivisible thing. Still wrong, but that's okay. Atoms of the same element have the same mass. So he was saying, hey, if you have a hydrogen atom, it's going to have the same mass as another hydrogen atom, or a carbon atom will have the same mass as another carbon atom. He also said that elements cannot be changed through chemical reactions. So all those alchemists who were trying to create gold out of other elements by throwing acid on them or causing chemical reactions, yeah, John Dalton rained on their parade and said, sorry guys, you can't make gold through chemical reactions. He also said that when elements combine, it's called a compound. So 2 or more elements chemically combined, that's where we get our compounds. Fast forward about a century. So 1904, J.J. Thomson comes along, and he's like, you know what? Atoms aren't just these solid spheres. There's little subatomic particles that make them up. And he discovered, through these experiments with gas, a negatively charged particle called an electron. Now, he knew that atoms were neutral. Atoms don't have a positive or negative charge, they're neutral. But electrons were a negative charge. So he hypothesized that protons probably existed. He didn't know where they were, his experiment didn't show, but he was pretty sure they existed. That takes us to Ernest Rutherford. Ernest Rutherford did this experiment called a gold foil experiment. He shot alpha particles through this thin piece of gold foil, and he expected that most of the particles would bounce back, thinking that atoms were relatively solid. Well, what happened is most of the particles actually went through. Some of them bent a little bit, but most traveled through that gold foil. And he was like, wait, how is this possible? Well, when he analyzed his data, he realized that atoms are actually mostly empty space, but they've got a positively charged center, which is what was causing some of the particles to bounce back, and some of them to travel through, and some to bend slightly. So he named this center the nucleus, and those positive charged particles protons. Now, a student of Rutherford's, Niels Bohr, decided to take this one step further. He was examining electrons, and he's like, hey, you know what? Those electrons don't just hover around the nucleus. They actually spin around the nucleus in specific orbits, almost like the planets revolving around the sun. So in Bohr's model, we have our positive protons and our electrons moving around in those different orbitals, those different energy shells that you remember from 6th grade. Now, we take this even a step further. We've got Erwin Schrodinger. Erwin Schrodinger kept looking at the model of the atom and was like, you know what? Bohr, you're not quite right. Instead of actually traveling in specific lines and orbits, they actually move super fast around the nucleus in a cloud. Kind of think about this cloud almost like the difference between a small road versus a freeway. Small road, the car only can go in one line. Versus a freeway, there's lots of places it could be, but it's still going to be heading in the same direction. There's just a lot more room. The cloud model is like a freeway versus a road. And this actually is the modern model of an atom. This is kind of what we use. Now, believe it or not, up until this point, neutrons weren't discovered. But in 1932, James Chadwick, who was a student of Rutherford's, he actually discovered neutrons. Before that, they didn't really know they existed. So he did another experiment with the alpha particles, shooting it through beryllium this time, and he realized that in that nucleus there are these neutral neutrons. Now this model, which we call Bohr model, but it's actually a mix of Bohr and Chadwick, that's the model we'll be using in class because it's easier to see and conceptualize, but the modern model of the atom is actually the cloud model. Now beyond this, we've got even more things. So in 1964, some scientists hypothesized about these things called quarks, and these are even smaller particles that make up neutrons and protons. And then in 1968, they had the evidence to support it. And then go a decade later, in 1976, some scientists hypothesized about gluons, which are the force that hold those quarks together. And then in 1979, they had experiments where they were able to show evidence of these gluons. So atomic theory keeps developing over time, and it's changing, and we're discovering more and more about it. So it's very exciting. But we've also got our basics. Atoms are the smallest particle of matter. We are going to study these three main subatomic particles, but know that just because we're talking about protons, neutrons, and electrons, there's a lot more to it than just that. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.